Good afternoon. My name is Salim Chapman. I'm a biomedical engineer specializing in biomechanics and human performance. I'm here today to give you a presentation on how you can improve the biomechanics of sprinting. It's undoubtedly at some point in our lifetime, each and every one of us have had an encounter with sprinting. Whether it be doing aerobic exercise in the gym, or in my case, dashing to class to be on time for that final exam. But very few of us know the proper technique associated with it. Even less of us know that there's any technique associated with it at all. But the fact of the matter is that there is. And if we can utilize the proper technique, we can increase both the duration at which we sprint and the rate at which we do it. The natural question is, what is this biomechanics? Well, biomechanics truly is as simple as it sounds. It's the study of how our body reacts to the laws of mechanics and physics. If you don't know these laws, don't worry. To truly understand the biomechanics of sprinting, you only need to know three simple principles. The first of which being Newton's second law of motion. Newton's second law of motion states that a force is equivalent to a mass times the rate of change of velocity. This is important in understanding how our initial acceleration contributes to our total force output throughout the entire distance that we run. The second force that we need to understand is Newton's third law of motion. Newton's third law of motion states, for every force, there's an equal and opposite reaction force. Well, this is important when understanding how any ground surface contributes to any motion that we take, because for every step that we take, we produce a downward force. And thus, according to Newton's third law, an opposite upward force is produced by the ground. This is what produces motion. This is what allows us to go. The third law that we need to understand is Hooke's law. Hooke's law states that for our elastic force is equal to the stiffness constant times its change in position. Well, this is important in understanding how certain muscles in our body contribute to our motion, primarily ligaments and tendons. These tissues are governed by Hooke's law. So, if we can increase the stiffness of these tissues, we can thereby increase the force that they produce. The next natural question is, what is this sprinting? Well, sprinting is generally a rather short distance. It generally only lasts between 60 meters to 400 meters. But in this short distance, it is certainly a huge synergy of power and speed. Let's focus on speed for a second. Speed is a contribution of two things: stride frequency and stride length. Let's start with stride length. Stride length is a component of three different distances: your takeoff distance, your flight distance, and your landing distance. Of the three, landing distance is probably the least important, but it contains a huge contributing factor because your landing distance creates the force that we talked about from the ground. In order to have good speed, you need to have favorable ground forces. So, you must focus on increasing landing distance, thereby increasing your stride length in order to have favorable reaction forces from the ground, which allows you to proceed at a much faster rate. Now, let's talk about stride frequency. Stride frequency is a contribution of just two things: your ground contact time and your flight phase time. Generally, at the start of a race, your ground contact time is an overwhelming 2-to-1 ratio to your flight phase time. But at max speed, your ground contact time is generally at a 2-to-1 disadvantage to your flight phase time. This understands that if we are having a faster output and our feet are moving at a faster pace, we're obviously going to run faster. But understanding that everything has a maximum output. So, we will reach a phase in which we aren't able to get any more stride frequency. And that certainly the only contributing factor will at that point be our stride length. I know we covered a lot of information here, but I hope it's been very helpful. That will conclude our presentation today. Once again, my name is Salim Chapman, and I hope you enjoyed it.